this presentation is in the topic of history of espionage photography, where we will be looking at, in this series, various types of espionage photography, the tools used to do them. This would best be accurately called biography of a photographic invention, because each of these videos will be about a specific, really cool, interesting, top secret photographic invention that used by the intelligence services of various countries. And I'll give plenty of background information and provide data that is very interesting and intriguing to people involved in the history of espionage, and how a whole bunch of unrelated things came together to create the actual device. On October 30th, 1961, at 3:31 a.m. in Washington, D.C., the Secret Service rushed into the presidential residence at the White House. They did an emergency evacuation of the president, the vice president, the Secretary of State, and a Speaker of the House from their respective houses, and took them to massive, ultra-hardened underground nuclear resistant facilities. Strategic Air Command had issued an emergency alert message or emergency action message. Nuclear bomb all across the United States were unsheathed, activated, and virtually every nuclear bomber in the United States got off the ground with their refueling aircraft. Everybody was assured that this was not a drill, and every missile silo that the United States had and every missile that was on board a submarine was brought and ready to fire. And the question was, what just happened? This is what just happened. The Russians had just detonated a 110 megaton hydrogen nuclear bomb. They had tamped it down to 33 megatons of yield because they were questioning the sanity of detonating 110 megatons. It was at a far north Russian test site. It triggered gamma radiation alarms all worldwide and created so much gamma radiation that all of these alarms saturated, and they saw bombs all over the earth because the sensors saturated and they could not direction find where it was coming from. At that point, it had been the largest nuclear bomb ever tested. The United States never saw it coming, and the United States never knew the USSR was building them. And I mentioned them because they built more than one of them. Kennedy's response was to recall the bombers, close up the missile silos, to keep the president at Camp David, keep the vice president at Raven Rock, which is a short distance away from literally as the crow flies. Then they moved the Speaker of the House to Mount Weather, which is right on the Appalachia Trail, as is Raven Rock and Camp David. And then they moved key congressional leaders, several people in Congress, to the Greenbrier Hotel in West Virginia. And then they hid all senior officials. Plus, they did one other thing. The president had his staff make a phone call to one nerd in Cambridge. This nerd was Dr. Land, the inventor of the Land camera, the Polaroid camera, Polaroid film, everything in that he designed. He was a national expert on the photographic reconnaissance. He was head of the Presidential Land Panel, which he headed, which is all about spy cameras, spy satellites. He was one of the designers of the U-2, the SR-71, and various classified spy planes that we still don't talk about today, and classified spacecraft to include the top secret Corona spy satellite. He was the man who gave us eyes when we could not see. And yes, Dr. Land was, until he died, an actual real spy, and he continued to be a spy until the day of his death. His recommendations, right after President Kennedy called him in, was that we needed giant cameras, behemoth cameras, bigger than a city bus cameras or a locomotive. They needed to be in outer space. They would use Polaroid film, of course, more on that later. They would use parachutes and secret labs and involve a black budget of hundreds of billions of dollars. And this was called the Hexagon camera, or the Hexagon project. Now, let's back up and look at what were we doing before this happened. From 1959 to 1972, we had the Corona project, which was 70 millimeter Kodak film. It could resolve a target 10 to 15 foot of resolution, essentially ISO 4. It was a stopgap program initiated next to the U2 program, and when there was the U2 shoot down of Gary Powers, the Corona project needed to be accelerated. Gambit, which came after Corona, was strictly a stopgap only. It used Polaroid or Kodak film, but the resolution was 24 inches, which is not that helpful. Hexagon was proposed to be the final apex of film-based cameras. It provided under 3 millimeters of resolution. It had an ISO of 0.024 to 0.4, very special Kodak emulsions. Think, if you're a photographer, think TechPan at 0.025 instead of 25 ISO, and all on an ultra-thin base, so you could get a lot of it in a satellite. Hexagon was the apex, but not the final keyhole project. Hexagon, this is a declassified photograph or drawing of Hexagon. It consisted of the stereo panoramic cameras, which did all the heavy lifting. Then there were film recovery units, which were little re-entry landers. And then there was a mapping camera. So the mapping camera took photographs of the stars that were present to the camera and put that on part of the film. Then the stereo panoramic cameras looked at the Earth. This way you could index exactly what the location was on Earth by looking at a star field. The initial length was to be 60 feet long so that it could be moved on a semi-truck. Diameter was to be 10 feet so that it could be moved by a semi-truck. And its weight was to be 30,000 pounds, again, so it could be moved on a semi-truck before the film was put in. This is the special semi-truck that they used to haul these cameras around. This, quite literally, is Route 95 in just outside Stamford, Connecticut. These were assigned just outside Danbury, Connecticut, at a company called iTech, and a couple other companies. But this is the completely nondescript. You can see the air conditioning and the heating systems on this. When these were transported, this was just commercial trucks, and then they had a team of security people inside the truck in case somebody tried to gain entry. But this is how big the satellites were. This is an article, a journal in which the Gambit and Hexagon were talked about, the peak of film return. This is a Central Intelligence Agency unclassified journal that they put out about monthly or so. So the National Reconnaissance Office the United States Air Force and the CIA did not operate the top secret spy satellite. It was operated by a secret agency at that time. The top secret name of the agency was National Reconnaissance Office, which meant it was a fusion entity between two other entities. So it was a fusion entity created and operated half by the Air Force and half by the Central Intelligence Agency. National Reconnaissance Office, when I served on active duty, it was still a classified name, so you did not utter the name unless you were in a SCIF or a command post. And we routinely got film in and images in from the Hexagon program. Initially, it was 3 ultra large format cameras. Its flight altitude was 50 to 125 miles. The initial design was for 4 re-entry film canisters, and then they changed that to 5. It was 55 to 60 feet long, based on did it have 4 or 5 re-entry canisters. It was 10 feet in diameter, and in 1968 dollars, each camera cost 1.6 or more billion dollars per camera in 1968 dollars. It was the largest and the last spy satellite to shoot film back to Earth. It's now all been replaced by digital systems, also thanks to Dr. Edgerton in 1984, where he developed a completely non-film based way to replace the film. It's fascinating that these two gentlemen worked on a lot of projects together. The Hexagon program was active in the air from 1971 to 1986. There were only 19 Hexagon cameras ever built and launched into space. However, those 19 Hexagon cameras mapped 877 million square miles of the surface of the Earth. And I know the technical geeks on here are really going to enjoy this. The reference orbit was 92.5 nautical miles perigee. The mission duration for the first 2 flights were 45 days. As the program progressed, missions durations were considerably extended beyond that, extending to 118 days on each of the last 2 missions. They also added ground coverage, where they added in 70 nanometer nautical mile width at 92 miles of altitude. So, they're 92 miles up. They're looking 70 miles wide with each of the cameras. The triple overlap photography with the quadruple overlap at the lower altitudes of over 100 nautical miles. The terrain camera resolution was extreme resolution at 4 micrometers when the satellite was at 92.5 nautical miles high. So from 92.4 nautical miles high, they had 4, not millimeters, micrometers, so they could measure the thickness of a leaf on the photographs. The eventual goal was to photograph 16 million square miles of denied space in Russia, China, and in the Warsaw Pact nations, and to do worldwide mapping coverage of the free world at a rate of 10 million square nautical miles per year, which is huge. The cameras were essentially 10-inch wide film for reference mapping, and then 6.6-inch wide stereo film. So they would take a section of film that was 6.6 inches long and 125 inches, 6.6 inches wide and 125 inches long, and they would move the film at 200 inches per hour through those 2 cameras, and they would get a long, very wide image because the lenses and the shutters were spinning, so that you have what is called a shutterless photography. Now, there were many matchups and mix and match films on the supply rolls. So they might have 5 rolls of film, but different missions. So different missions required different film be spliced together to be put on the rolls. They could get up to 320,000 feet of film load, or 60 miles of film load inside the satellite. 1,900 pounds of film per foot reel times 2 reels, which gave them a film load of 3,900 pounds. That's just 3,900 pounds of film. And I know every art school student just gasped because things they could do with that much film. Now, here are the various types of film that they used. They would typically fly with 123,000 feet of Kodak 414 film, which is a black and white medium thickness base, or they would fly with 144,000 feet of type SO206 black and white thin base, or they could mix it up and or also fly with 150,000 feet of type SO3 1.2 mil ISTAR base. They could also fly with and or 168,000 feet of type SO255 natural color, like trees and things like that, and or 160,000 feet of SO130 infrared film. And then they modified TechPan from Kodak, where they could load 215,000 feet of modified TechPan, which they used only in the later flights because they had a lot of issues with the gallium that they used to break down the dye clouds in TechPan and temperature issues. A great deal of this was shot on infrared, black and white thin base, and then also the same thing shot at the same time on natural color base. So there is 6 types of film that they used. And this is a lot of film. And then they would take the film, get the capsules, take the capsules to a processing station, and then hand the film off to Kodak. They actually had the Red Eye facility dedicated just to process this film. And at one Air Force base, they had a lab where they could break down in case something happened in Rochester, where they could break the reentry capsules down and process the film there as well. The camera itself is a Perkin-Elmer. Take that back. This is the main stereo camera. Is a panoramic camera, a Perkin-Elmer camera, f3, aperture of f3, focal length of 60 inches, and an aperture adjusted out to 20 inches. The 60-inch focal length was only on the early versions. There were 96 inches on the later versions. The aperture of f3 on some of the laters, and then to f2 on the earlier models, and f2 on the later models. It was a 6-inch film width, and there were several variants of 40-inch focal lengths with an aperture of f1.5, and it was on what's called a modified Schmidt system folding right lens. The mapping camera, which was not pointed at the Earth, but what was pointed at stars. There was a 12-inch camera, and then a 96-inch on later versions because they found they needed to look out further. It was an aperture initially of f6, and then there were several variations of 176 millimeter focal length at f4, because these were designed to lock onto stars, and as the satellite moved, it took photographs of the star field at the same time it took photographs of the ground, so they could determine exactly what the camera was looking at in outer space and then transfer that down to ground, which made it extremely easy to index where the maps were pointed at or what the maps were being taken of. The initial launch was July 1970. It was designed to do a short duration operation. It was a 31-day mission over the Soviet Union, China, and North Korea. The final launch was in 1984. It has been mostly replaced by real-time, mostly digital spy satellites. The control points are and continue to be at Cadena Point in Oahu, Sunnyvale, California, New Hampshire, at a city called New Boston. There's a Air Force tracking station for Manchester, New Hampshire. That was built for the Hexagon station. So you've got Cadena Point, you've got New Boston, Sunnyvale, and there are 3 sites which continue to be classified that were used for Hexagon, but which are used for some more up-to-date, and because they're used for some of the more up-to-date, much more classified systems, they will not be discussed here. The results was an astronomical success. 320 miles of USSR was photographed on every panoramic view, on every kind of film. They got extremely high resolution of the entire country of China, USSR, North Korea, and a number of Warsaw nations. There were the fact that they did repeated missions and multiple satellites over several decades permitted a massive intelligence harvest against Russia, China, North Korea, and others.